Welcome to the SimTraffic software video for the Missouri Department of Transportation. This video corresponds with the MoDOT Engineering Policy Guide, EPG, 905.3.5.3.1. This video consists of 6 sections. They are Introduction to SimTraffic, Key Simulation Settings, SimTraffic Model Runs, Queue Lengths in SimTraffic, Using SimTraffic to Mitigate Excessive Queuing, and MoDOT SimTraffic Model Reviewers Checklist. This video will review the SimTraffic software best practices, as well as discuss how to use SimTraffic to mitigate excessive queuing. To learn more about how to use the software, please refer to EPG 905.3.2. Let's begin with an introduction to SimTraffic. SimTraffic is a microsimulation software that simulates the movement of individual vehicles based on vehicle and driver behavior theories. Microsimulation models are good for large-scale transportation facilities and for analyzing interactions with other vehicles and adjacent intersections to help determine MOEs. An important consideration is determining if the project being assessed is appropriate for the extra levels of effort and large computer processing time and storage requirements often needed for microsimulation models. Common microsimulation tools include SimTraffic and Vism. This video module will focus on SimTraffic. SimTraffic is utilized within the Synchro software application and performs microsimulation and the animation of vehicular and pedestrian-related traffic. SimTraffic allows the user to specify the number of model runs and the types of measures of effectiveness, MOEs, to quantify in auto-generated summary reports. The SimTraffic software displays its animation while the simulation is being performed. SimTraffic microsimulation software is good for analyzing adjacent intersections to help determine MOEs. Since each individual vehicle will react differently to the influences of other vehicles, pedestrians, bicyclists, roadway geometry, and grades, models with the same geometric and volume inputs will generate slightly different results, similar to how an intersection in the field will perform differently day to day under otherwise identical conditions. There are several best practices for coding key simulation settings. Refer to Missouri Department of Transportation's Synchro training module for best practices on coding roadway networks in Synchro. SimTraffic simulation specific information can be entered in the Synchro user interface by clicking the simulation settings icon and entering data into the simulation setting table. The user can also use simulation settings in Synchro to make the network more closely resemble actual field conditions and/or make it look more aesthetically appealing. Except for the lane configurations and volumes, the simulation setting table is used to influence driver simulation settings in SimTraffic and does not influence Synchro MOE calculations. In general, field data should be used when applicable. In the absence of field data, refer to EPG 905.3.5.3.1 for suggested key Synchro or SimTraffic parameters with specific MoDOT guidance for proper application. Let's discuss some of these simulation parameters. The lane alignment parameter determines how lanes align through an intersection as shown in these example diagrams. Synchro default values are right for right turns, left for left turns, and right NA for U-turns. It is important to ensure that the default settings are correct when the number of receiving lanes exceeds the approach lanes. The Enter Blocked Intersection setting controls simulation modeling gridlock avoidance. This can be set to yes, no, 1, or 2. For example, a selection of 1 or 2 will allow 1 or 2 vehicles to enter a blocked intersection. This is typically used for unsignalized intersection side streets. For most MoDOT applications, set the parameter to 1 unless otherwise specified or not appropriate. The two-way left turn lane, twiddle, median setting is used to visually display a twiddle median. Simulated vehicles will not actually use the twiddle median. The median width parameter sets the link's median width. Left turn lanes are considered to be positioned in the median even if they are not defined as storage lanes. The setting is synchro calculated, but it can be overridden. Default values that have been overridden show up as red. The link offset setting is used to offset the roadway alignment to the right of left of the center line, as shown in the example diagrams. This can be used to create a dogleg intersection if there are no internal stop bars. The turning speed parameter is used to set the turning speed of vehicles while inside the intersection. This setting is utilized in SimTraffic only, not Synchro. The default left turn value is 15 miles per hour, and the default right turn value is 9 miles per hour. It is recommended to use the Synchro or SimTraffic default values for the turning speed attribute. However, for intersections with large turning radii and for the modeling of intersections with freeway entrance or exit slip ramps, the turning speeds can be adjusted higher if set to reasonable ranges. Now, let's discuss the options for SimTraffic model runs. Once SimTraffic is open, a couple steps should be taken before utilizing SimTraffic simulation and animation. Under the calibration section in SimTraffic, calibration parameters can be established for vehicles, drivers, intervals and volumes, and UTDF data options. Under intervals and volumes, networks should be seeded for a period long enough to transverse the two most distant points of the network, including stops. The recording interval duration should be 60 minutes unless otherwise justified. It is recommended to break the recording duration into 15-minute intervals with PHF or peak hour factor adjust for one of the middle intervals set to yes. The other intervals should have anti-PHF adjust set to yes. It is recommended to start with the SimTraffic default values for the drivers and vehicles parameters. The vehicles page can be used to view and edit the vehicle characteristics. For example, to simulate a higher proportion of certain heavy vehicle types on known freight corridors, the proportion of truck types and/or buses could be adjusted higher. For all microsimulation models, It is important to complete multiple simulation runs per peak hour scenario. Completing multiple simulation runs accounts for the variability in traffic flow patterns, whereas completing only one simulation run would be the equivalent of assuming that peak hour traffic on one day is representative of traffic on all days throughout the year. Multiple runs can verify model results by minimizing the influence of outlier runs, as well as accurately quantify the results of higher delays and queues. The recording interval duration for each run should be 60 minutes unless otherwise justified. The MoDOT EPG 905.3.5.3.1 recommends completing between 5 and 9 simulation runs in SimTraffic per peak hour scenario. For example, a minimum of 10 cumulative runs should be completed if analyzing both AM and PM peak hours. It is advised that the modeler stick to the lower end of the range or a lower number of runs if there is a low volume demand and minimal congestion on the transportation network. It is also advised that the modeler conduct more runs if there is a high delay and excessive queuing on the transportation network. We'll move forward now and discuss queue lengths. Synchro reports calculated 50th percentile and 95th percentile queue lengths, while SimTraffic reports the simulated or observed queues for the average, maximum, and 95th percentile queue lengths. Both programs estimate queue lengths to the nearest foot. Since SimTraffic is a microsimulation program, it observes each individual vehicle and documents whenever a vehicle is traveling less than 10 feet per second and behind a queue of vehicles. This process can often lead to different queuing results than Synchro, especially when queuing vehicles from adjacent intersections are influencing the subject intersection. Synchro is explained in more detail in another video, but is being used here as a comparison to SimTraffic. It is advised that Synchro 95th percentile queue lengths and SimTraffic maximum queue lengths be the primary metrics reported. In particular, Synchro 95th percentile queue lengths that are near capacity or over capacity should be compared to SimTraffic maximum queue results to verify the queuing issue. Observed SimTraffic queue lengths can be displayed visually, as shown in the graphic on your screen, by using the Static Graphics tool under the Options tab in SimTraffic. A mitigating strategy for a project could include recommending longer and/or additional storage lanes to mitigate excessive queuing. All instances where the SimTraffic maximum queue length or maximum observed queue exceeds the storage bay length should be addressed where possible. The SimTraffic maximum queue or the Synchro 95th percentile queue, whichever is higher, should be used in determining recommended storage lengths. The SimTraffic 95th percentile queue should not be used since it is statistically calculated from the mean queue and the standard deviations. Excessive queuing identified in SimTraffic should be reviewed for appropriateness and unrealistic lane blockages. Lane blockages may occur when turning queues extend beyond the storage bays and block through traffic, or when through queues extend beyond the turn lane storage bays and block turning vehicles from entering the turn lane. SimTraffic can help determine the minimum storage bay lengths to to recommend in a project's mitigation scenario. Other factors, like closely spaced intersections, freeway ramp terminal intersections, or professional judgment, can lead to recommendations for longer storage than the minimum based on the SimTraffic results. The user would complete the following steps. Develop a copy of the Synchro or SimTraffic file specific to this mitigation scenario. In Synchro, remove the storage bay distant attributes at all intersections. This removes the storage bay distance constraints and transforms the former storage lanes into full travel lanes. This will provide the turning movement with the storage capacity of the length of the roadway link. It will also allow SimTraffic to analyze what the queue lengths will be without the constraint of the storage bay's length. Run SimTraffic at least 5 times for each peak hour scenario. Review the longest SimTraffic maximum queues for each location to determine a preliminary length to set the storage bay for these locations. Since SimTraffic maximum queues will likely differ between the various scenarios and peak hours, it's important to review the results for each to determine which results in the longest maximum queue. Recode the network to include new storage bay lengths, rounded up to the nearest 25 feet from the SimTraffic maximum queue lengths, and finalize the documentation. Every Synchro or SimTraffic model submitted to MoDOT should be reviewed by a member of MoDOT staff using MoDOT's Model Reviewers Checklist. To encourage agencies and consultants to review their work prior to submitting, this checklist has been made publicly available. The items in this checklist can be found in EPG 905.3.5.6. Modelers and reviewers should refer to these sections if they need clarification on MoDOT's best practices regarding Synchro or SimTraffic. The checklist assumes that the basic guidance from the manual is followed. However, if deviations from the guidance were agreed upon by the project team, these supersede what is written in the checklist. When using the checklist to review a model, a mark in the check column by the reviewer indicates acceptable items. A mark in the NA column indicates that the item does not apply to the model being reviewed. If an item applies to the model being reviewed but is deemed unacceptable or in need of adjustment, both check boxes for that item should be left blank, and the reviewer should address the issues with that item in their comments at the end of the checklist. Now, let's discuss key takeaways and additional resources. This presentation covered some general best practices for using the SimTraffic software, as well as information on how to use SimTraffic to mitigate excessive queuing. The MoDOT EPG contains an abundance of information about using SimTraffic as an analysis tool. Additional information can be found in the MoDOT EPG. Time to see what you know. Question 1. True or false? All simulation table-specific settings in Synchro are used to influence driver simulation settings in SimTraffic and do not influence Synchro MOE calculations. The correct answer is false. The lane configurations and volumes at the top of the table do influence Synchro MOE calculations. The rest do not. Question 2. What is the minimum number of simulation runs that should be completed for each peak hour scenario? Is it A, 3, B, 5, C, 9, or D, 10? The correct answer is B, 5. It is advised that between 5 and 9 simulation runs be completed in SimTraffic for each peak hour scenario. It is typically determined to use 5 SimTraffic runs when there is a lower volume of demand and minimal congestion on the transportation network. Thank you for watching this video on TIA guidance for SimTraffic. We encourage you to view the other TIA guidance videos. If you have any questions, please reach out to MoDOT Central Office, Highway Safety and Traffic.